Hi, everyone. Thanks for joining. We'll just give everyone a minute to kind of get in their seat and get settled, and then we'll jump right in. Okay, well, it is time, so let's go ahead and get started. Hello, everybody. My name is Crystal Shaughnessy. I am the event specialist at EDB, and I'll be your host today for our webinar. I am joined by EDB's Jamie Watt, who is our Senior Vice President of Support Services, as well as William Ivansky, our Senior Principal Support Engineer. And we'll be presenting today on Avoiding Postgres Distress, Part 1, Flying Solo. Before we get into that, I'd just like to review a couple of housekeeping items together. Firstly, please note that the presentation is being recorded. We do plan to share both the slides as well as the recording with you at the close of the broadcast, and that will happen via email, so please keep an eye out for that. And secondly, you'll see that the lines are currently muted. Though we do expect the presentation to last most of our time today, we do plan to take questions throughout and at the end, time permitting. So please feel free to put your questions into the Q&A box. I will do my very best to monitor the chat as well, but we'll of course give priority to anything we see in that Q&A box. So with that, I'll hand it off to Jamie to kick us off.
Thanks, Crystal. So, as mentioned by Crystal, I'm Jamie Watt. I'm the Senior Vice President of Support Services at EDB. So that entails our technical support, our remote managed services, as well as our cloud support teams across the globe, now in about 16 countries, actually. And joining me today, we've got William Ivansky. William, if you want to take a moment to introduce yourself.
Yes, I'm one of the support engineers at EDB, and I help also with other tools as well. For example, Lasso, Live Companion, or MiniDB.
Thank you very much, sir. So between the two of us, we've got probably more years of Postgres experience than we do fingers and toes. So today we're going to be talking about, as mentioned by Crystal, the overall way in which people tend to navigate and could navigate open source, but in particular Postgres, and what the pratfalls are, which are potential and ahead of folks as they kind of enter that journey, and what they might run into along the way as well. So jumping into the metaphor pool, going into open source waters in general can be a complex endeavor for operations that have historically operated in either four-wall type solutions or something that is more inclusive in terms of a enclosed solution, right? Going into open source gives you the opportunity of freedom as well as flexibility, but it also introduces complexity, right? Database design, even absent that condition, is complex. Now, database solution design in the waters of open source is inherently more complex, given all of the factors you have to rely on. It's sort of analogous in some senses to open heart surgery on a roller coaster, right? For the sake of simplicity, we're going to be focusing here on the journey rather than on the shipbuilding experience itself. Database solutions are built for purpose, but they're configured for need, right? So does it actually adhere to the organization's requirements for ease of use? Is the performance actually meeting the requirement of the applications, the infrastructure, and the customers at the fore of the need for the platform itself? Is it available and resilient in the event of issues that might be geographical, could be regional, or otherwise? And is it easy, or at least sufficiently easy, to maintain where you're going through upgrades, patching, and so forth? So you want to make sure that your solution is both harbor tested and peril ready, right? So ensuring that as one's going through the process of the design and ultimately into deployment, that things such as query testing, connection handling, and overall connection load, and the ability to scale both in terms of connections as well as load, complexity of queries, is there and inherent in how the design is implemented into a production environment. You want to make sure it's peril ready though, right? Because life happens, right? Connections will fail, connections may fail en masse, and saturation can occur as well. And how does your solution handle those? failover and availability in the event of a network issue, or it could be a host issue, could be a site issue, could be a region issue. How does your overall solution handle failover? How does it handle availability in the face of such sort of challenges? And then backups and recovery, right? You need to make sure that failing those other two components or the other two layers in the overall stack, that you have the ability to actually rely on backups that are current, that are consistent, and that can be relied on for an up to the minute or up to end period resolution and restoration time. So the journey itself looks very obviously expansive and beautiful on the surface, right? You have flexibility, freedom, and modernization. And these things, although a little bit ephemeral, tend to drive the desire to get into this sort of a path, right? Stepping into this path gives people the flexibility to decide what is the right solution for them and not necessarily have to rely on what is a prescriptive recipe book that is put together by one or more vendors, right? It allows the customer as well, or the user, to also have a voice and potentially a hand in what is produced as that open source project, contributing to or committing code that could improve the project longer term. Doing so effectively means that you have to be focused not only to the horizon, to those components of the journey that are as freeing and as advancing as they can be, but also you got to look beneath the surface, right? When you're looking beneath the surface, you see kind of the lower level details that could lead to the challenges we talked about a moment ago: replication, availability, performance, scaling, and again, the maintenance aspect of upgrades and patching. So let's go ahead and jump into some of those scenarios. Today, we're focused on some of the experiences that we see from the perspective of the support services organization, which admittedly is kind of taking the slant of viewing the world through the eyes of the emergency room or urgent care. But it tends to be kind of a pragmatic view of what we see in terms of challenges or at least opportunities that individuals may face. Remember, going into open source doesn't necessarily mean that you have to be flying blind. Flying solo just means that you have to do so in an increasingly confident and responsible manner. So without further ado, we're going to touch first on high availability and replication. So the first scenario that we're talking about is actually a customer had reached out to us. They ran into a situation where the primary was actually failing over to a remote replica. And unfortunately, that remote replica wasn't actually able to service the workload, both due to latency as well as the horsepower in the replica's underlying infrastructure. So, William, what did we actually find when we went through kind of the search and rescue efforts of that?
Yeah, so initially, the customer was not aware that the failover happened, and they started to get performance issues and users complaining about application performance. And then it's how they figured out that failover to a remote replica had happened. So we reviewed the logs, and we found that during low traffic time, what happened is that the primary was isolated from the network, and this is how the remote standby was promoted. So it was a genuine failover because the primary was isolated, and when this happens, as the customer has automatic failover enabled, then the replication management tool creates a recovery conf file on the primary and stops the primary. So even the customer had attempted to start Postgres on the primary was not possible to be used as a primary because of the recovery conf. If it was, depending on the Postgres major version, then the same safety mechanism would be written not to the recovery conf file, it would be written to the Postgres autoconf file. So it was a failing restore command that was written to the recovery conf file as a safety mechanism. So
now this presents a couple different potential pratfalls for them, right? Because it's not just the fact that they had a failover to a replica which they hadn't foreseen, or the fact that it was not necessarily as potent as what they were seeing with their primary's capabilities, but it also could have presented issues in terms of data consistency, right?
Exactly, and this is exactly what we tracked as priority in your investigation, the customer was in an urge to actually perform the switch back to have performance restored. But we reviewed the logs and we made sure that there was really a low traffic time. And when the remote replica was promoted, there was no difference. It was the same LSN, so there was no data divergency. And the promoted primary had all data that was written at the former primary at the time the promotion was happened.
So a little bit serendipitously, things that happened in such a way that they were actually able to go back to, the original primary. We were able to help them get back on their feet, but we were also able to uncover the fact that, the monitoring that would have allowed them to realize that they had a failover to begin with would be put into a place such that they were going to be capable of alerting and reacting appropriately as well, right? And it sounds like we also made some additional changes from how they would handle the failover on a larger scale as well, right? The solution is only as robust and as intelligent as it is implemented.
Exactly. Yeah, so we are able to help the customer to perform the switch back. We're able to adjust the restore command. So this safety mechanism really requires a manual adjustment because the primary is taken down like that to avoid data issues and also to allow the customer to investigate what happened for the failover to happen in the first place. So a configuration in the automatic failover was needed to adjust the order of the standbys or even the priority of the standbys as they are promoted or even disable the remote standby. Mm-hmm. So this standby is not promoted in the event of a failover. And also, as I mentioned, monitoring is important because whenever a failover happens, the customer needs to be made aware as soon as it happens in order to avoid, if there is data inconsistency, in order to avoid data to be spread.
Got it. So what seemed to be a fairly simple problem ended up becoming an opportunity to dramatically improve the resiliency of the overall solution.
Exactly.
Okay. Well, jumping into the next one, error canceling statement due to conflict with recovery. Seems to be rather precise, but also not necessarily very thorough in terms of what is the consequence of this error. So, William, what did we see when we got pulled into this engagement?
Yes, in this case, the customer had a very important standby that was used as a reporting server. So there were several queries that were happening against this standby. So we investigated the logs and we found that there were queries that were running for longer than 30 seconds, which is the default delay value. And those queries, they were happening constantly. And it was not like a reporting job that started during a specified period of time, for example, during the night. So yeah, so if it was a specified period of time, then we would be able to suggest the customer to, for example, pause the wall apply.
But given the fact that it was a consistent demand and it was likely causing issues on the primary where you're creating these contentions on the standbys, what was the path that we took to actually get the customer to a healthier place?
Yes, we provided multiple suggestions. One of them is to increase the max standby delay, either streaming or archive. It depends on how the standby is receiving information from the primary. And that allows queries to run for longer before they are actually canceled because conflicts with recovery. So it's important to understand that the conflicts with recovery happen because there is a maintenance procedure running on the primary out of vacuum that is retrieving rows that were marked as to be removed. And those rows are still needed to be used from the queries running on the standby. So when Postgres notices on the standby, when Postgres notices that there is this conflict with the recovery, Postgres automatically pauses replication and allows the query to run. But the query can't run indefinitely, right? Because otherwise, replication will be paused with pauses replication lag, and while retention, it would be paused indefinitely as well. So by default, it's 30 seconds, but the customer can increase that delay. Sometimes this helps depending on the nature of the queries, but there are times where actually enabling hot standby feedback is the recommended approach, because then the standby would be allowed to send signals back to the primary and coordinate with the primary which rows are actually needed by the queries being executed on the standby. So
how does that help prevent or at least reduce the probability of the problem that they saw?
Yes, so hot standby feedback enabled allows the standby to signal back to send signals back to the primary, and the primary will understand that those rows, those tuples are still needed for queries in general, and then out of vacuum maintenance will not consider those as marked to be removed. So we won't see this conflict with recovery happening. But on the other hand, and it's important to understand that the same bloat that would be caused by those tuples to be maintained and not removed by out of vacuum, that would be caused if the queries are executed directly against the primary. They would also happen if we enable hot standby feedback on the standby. So it depends on how long and how many queries are executed on the standby. Because when it's enabled, then it's like if those queries are executed against the primary itself. So
got it.
The third option, we should allow for a more consistent reporting server is to actually have a logical standby. So to replace the physical standby with a logical standby. The logical standby is a primary itself, and auto-vacuum routine is independent from the primary. So you can run queries against the standby, and the nice feature about having a logical standby is that even though the data is received through WAL, the logical standby only applies data changes and not auto-vacuum changes, not page changes. So the standby, the queries, the long-running queries can be executed against the standby, the logical standby in this case, and this allows also for more complex reporting solutions, for example, using materialized views that can be refreshed only on the logical standby, reducing this work from the primary.
Now, does that cover, I mean, it's a little bit indirect, but does that cover other scenarios in which we might see that the logical standby is more recommended? That was one of the questions we just had posed in the audience.
Yes.
So the question is, in what scenarios would the logical standby be more recommended when we see situations such as this?
Yes, if you have queries, so the demand is too high of long running or too many queries being executed, then it's recommended to consider using a logical standby instead of a physical standby.
Thank you. And there was an additional question. By increasing the delay on the standby, is there an increase in risk of data loss in the event of the primary failure? And I think that probably goes back to how they've actually got their commit configured as well. But would you like to comment more on that?
Yeah, the delayed standby would act as if a replication is paused. So
yeah, I think that their question was more by increasing that delay. Is that delay and the window in which you increase it going to create a larger pocket of risk for data loss if the primary were to fail?
Yeah, so it's delay in terms of apply and not in terms of receiving WAL. So even though the standby has already all data that it's received from the standby, then if, for example, the standby needs to be restarted, then it would apply all files available, and it would have all data. And it's only an applied delay in the sense that these WAL files, these data changes are not being applied. So they are not available if you connect to Postgres and you would check the data there, the logical data, then this data is not available. If you perform a failover and you promote the standby at that point, then yes, you would see, if the standby was paused because of this, then yes, you would see the delay in the data as well.
But the wall has actually already been shipped. It just hasn't been applied as of yet.
Exactly.
Got it. Okay. Thank you. So, thorny already, but I think we've got some good questions as well as some good branches off from the original examples as well. So, the next issue we saw was, sorry, too many clients already. Again, fearfully ambiguous, but we had jumped into the overall troubleshooting to understand a few different aspects as to what could be causing that. And William, what did we find?
Yes, this sorry, too many clients already happens when there are more application connections trying to connect to Postgres, then the maximum number of connections per Postgres configuration is allowed. So this happens, for example, when applications are scaling, when new applications are being added to the same instance, and there is no configuration. There is no configuration change in the application regarding the size of those, the amount of those connections that can be kept against the database. So this happens, for example, when the application has its own connection pooling mechanism to keep connections open against the database to reduce the overhead of having to open connections all the time. So what happens in this specific case is that by checking the pgstat activity, even though a regular connection is not possible to be made to Postgres, then we still have the super user reserve connections to perform such a diagnosis. So we saw that most of the connections were idle and were actually at some age. So this sometimes can be tempting because when the user understands that this is being limited by the Postgres configuration and by default max connections is set to 100. When this is limited by the Postgres configuration, it can be tempting to just increase max connections and allow the number of connections that the application needs at that time.
Can be tempting, but not necessarily the path you want to go, right? I mean, where you see that many idle connections, you don't know if it's because you're intending to persist, or it could be possible that nobody's doing explicit closes, depending upon what the application is expecting for database behavior, right? So where we start to get into, remedy and path to success, what were the recommendations that we made?
Exactly. So we explained to the customer about the recommendations, and actually the connections that are allowed to Postgres, they are limited. It's recommended that they should be limited to the available resources on the servers. So if those connections, they are idle and you have too many connections idle, and out of sudden application receives a peak of load and those connections, many of those become active, then you can cause a resource contention on the server, because all of them will start to compete for resources on the server, and those resources, they are not available. So Postgres will have to context switch on the backends. They will need to context switch.
Okay. And again, where we're seeing this sort of error, you could actually conceivably see it even if you're using a database side pooler as well, right? It all comes down to kind of how you're configuring this, so that way you've got the right outcome coming from both your overall gatekeeper, right, in terms of the balancing, the pooling that you're doing on the database side, as well as what you've got the database itself configured to. And that's kind of a good segue into the next example. So in the next scenario, we saw PgBouncer client and query timeouts. So what did we see when we jumped into that?
We saw that there were client and query timeouts, and that was from the point of view of application. And the customer initially thought that there would be a resource contention happening on either PgBouncer server or the database server, and that was not the case. The load was still feasible to receive more connections. So actually, by seeing that there were clients waiting, maybe there were some adjustments from the customer side to increase the max connections on Postgres or increase max client con on PgBouncer side. So that would be like applications would be allowed to reach the database. So that was not what was happening. The bottleneck was in a different configuration. So we reviewed the configuration and we found that the default pool size is still set to 20 on PgBouncer. So a pool in terms of PgBouncer is a database and user pair. So the default pool size limit is how many concurrent transactions or how many concurrent sessions, depending on the PgBouncer transaction, on the PgBouncer pool mode. Limit is on how many concurrent of those of the same pair, database and user, can be allowed at the same time.
Now, inadvertently, the pool size was actually affecting some of the other configurations that they had in play from creating a bigger problem, right?
Exactly. Yeah, so they try to increase max connections and max client con in an attempt to resolve the issue, because what they were seeing in show pools was clients waiting. So actually they were limited by this configuration. So increasing this a bit would allow to receive more pairs of concurrent connections of the same database and user pair.
Great. So what got us to a place where they felt that we were able to address the problem? What sort of recommendations or changes did we put in play?
Max connection should be, as in the previous case, max connection should be configured in a way that it actually respects the available resources on the server and actually what's the required load that we can see from the application, right? So max connections is too high. The number of allowed clients on PgBouncer can also be too high, because 10,000 client connections, if we are not allowing all of them to arrive to the database, they are just waiting on the PgBouncer client queue.
Okay.
So, yeah. So
sorry, go ahead.
In order to achieve the optimal configuration settings, even for the default pool size, the customer needs to take into account all pairs of database and user, essentially all pools that are reaching this database. Great.
So there was one question, well, there's a couple, one we'll hold till the end, but one relative to this question or to this issue. Can the database max connection parameter be changed online, or requires a database bounce? I believe you do actually have to restart the server itself. You can't just do a reload of the config once you apply connection changes.
Yes, it requires a restart.
Okay. Great stuff so far. Thanks, William. So jumping into durability and performance, right? So we've made sure that it's actually highly available. We've got replication functioning. We've got queries actually not holding up traffic. So how durable and how performant is the overall solution? Well, one example we ran into, a customer had reached out and they were seeing a system outage as a consequence of pgxlog, pgwall, resulting in disk exhaustion. So when we jumped in, William, what were the steps that we took and what did we find?
Yeah, we reviewed the logs, and we noticed that Postgres was taken down because when trying to write a new WAL file, there was not enough disk space. So yeah, at this point, to protect the data, Postgres shuts down. We also reviewed together with the customer, we've reviewed what happened before. So the customer had this disk exhaustion. They were able to check the logs, and they added an additional expansion to the available storage. So Postgres was started, but still the storage that was expanded was about to be exhausted as well. So we reviewed the history of this with the customer, and we asked for changes that happened in the customer had performed a test when trying to set up a logical standby for the server. So the WAL files and the disk exhaustion was explained by this, that the WAL files were accumulating in the PgWall directory because there was an inactive replication slot. So when we confirmed that there was inactive replication slot, we explained the root cause for the customer regarding why the disk exhaustion happened in the first place. But that replication slot being inactive, that depends on other information as well. Should this replication slot be used by, for example, a standby that should be started? So it might be affecting other portions of the customer's business in this case. But the customer confirmed that this was a test and was able to drop the replication slot. And after a checkpoint, the WAL that was accumulated was removed from the disk. So disk storage was retrieved, was made available again.
And this is, of course, another example where, well, one, you never want to be testing things in production, but two, that there was an opportunity for a logical standby to actually be performing any of these test activities against. Is that correct?
Exactly. Yeah. So one idea is to have a logical standby of production, or even a completely different environment that you can, for example, recover backups. So if you have daily backups, you can recover the backups and destroy the staging environment and rebuild at every recovery. And with that, you are applying the good practice of actually testing backups. So you can have a staging environment like that, and you can test architectural changes like that. For example, adding a new logical standby, you can test in a separate environment. The other point to this, besides testing activities in production, the other point is monitoring. Several monitoring solutions would be able to catch the inactive replication slot and even the disk usage depending on a threshold, and we would be able to identify this faster than actually a system outage.
And certainly in the several recent major versions, things like REPL-stat activity, like there are a lot of things which have gotten a lot more granular in order to have more visibility for monitoring for users and for administrators to make sure that they don't run into these problems, right?
Exactly.
Great, thank you. So the next one up was performance degradation on queries against a Postgres foreign data wrapper, or specifically Postgres FDW. So when we jumped into it, what did we find?
Yeah, so the customer had implemented this solution using Postgres FDW, and they noticed that initially when the solution was applied, the queries were faster, but they degraded over time, a few days of usage, and the queries started to have poor performance, or of course, the performance depends on a threshold specified by the user. So they noticed some queries that those queries are using the foreign tables. So they have implemented the import foreign schema command to have the foreign tables mapped into the local database. And they noticed that those queries, the query plans of those queries was showing performance degradation. So we investigated the issue, the information that the customer provide, and together with some catalog information that we can gather, for example, the statistics of these tables, then we noticed that the foreign tables they had the statistics outdated. So yeah, so this is part of search and rescue. Then the remedy. The remedy in this case was to identify the foreign tables and run and analyze on those tables. This is the performance of those queries by immediately. And going further, we recommend the customer to have an actual routine of performing analyze against foreign tables, because foreign tables, they are not considered in the auto vacuum routine. So regardless of the FDW solution, those foreign tables, they need to be analyzed separately for query performance, right? So if the statistics are not updated, then the query, when performing the query, the Postgres might not choose the best query plan, and you can see the performance degradation in the queries. Now, specifically to Postgres FDW, there is an option called use remote estimate, and the customer can enable this. And what's going to happen is that instead of relying on the local statistics, Postgres, when running those queries, Postgres will rely on the remote statistics for the tables that are foreign tables. However, this has a cost, and depending on the complexity of the queries, Postgres can perform multiple round trips to retrieve the actual explain plans from the remote server. So if this is a query that is complex but not executed very often, then this can be a recommended solution for those queries only. Or if the table on the remote side is heavily written and the statistics are very volatile, so in those cases, then it's recommended to rely on the statistics from the remote side, because it depends on how often you run analyze on your local database. Then the statistics might not be able to catch up with the statistics that are constantly changing on the remote side. So for in summary, for complex queries and not executed very often, or if the tables are heavily written on the remote server, knowing that in this case it would be preferable to have shorter queries with less complex query plans to avoid the number of round trips that would happen when performing the queries on the local database.
But if unavoidable, then you have to take that into consideration when you're doing your cost-based analysis for how the actual instance is going to perform, right?
Exactly.
We had a question that was just put in. How often should table and index statistics be updated in general? What is the recommended strategy to update object statistics?
It's completely load dependent. So it depends on the changes that are happening on the remote side as well. So you would need to come up with an analysis around the number of changes that are happening there, and also enable log auto vacuum on the remote database to see on the foreign tables on the actual main tables what's auto vacuum performing for better performance on the remote side. And then you can mimic a similar, for example, similar periodicity of running auto vacuum on the local tables on the actual foreign tables.
Okay. Moving on to the next example. So still waiting for exclusive lock on extension of relation. So what did we see here?
Okay, so in this case, the customer had a table that was already partitioned by month, and the table was heavily written in append most, and most of the transactions were actually performing inserts against the partition table. However, the transactions are being routed to the last partition, to the current partition, and the current partition receiving that many inserts. At some point, the new tuples will require more disk. So the extension of relation means Postgres is allocating more disk from the operating system.
Okay. So given that, what were suggestions that we made to actually try and address this? And this is kind of more, it borders on architectural advice in terms of how one's going to approach their Postgres instance, but let's hear a little bit more about that.
Yeah, so if the table is heavily written like that, then some inserts, several inserts, they can be executed and not actually finishing, while one of them actually requires the exclusive lock to perform the extension of relation. So the extension of relation has to wait for all those inserts that started before the actual lock to finish, and then the exclusive lock has to wait. Now, further inserts that try to be executed, because how locking mechanism works, further inserts that try to be inserted against this partition, they also have to wait, but then they wait against the lock and not the IO contation itself. So in those cases, we recommend to apply hash partitioning if the table is not partitioned yet. If the table is already partitioned, for example, by month, then each monthly partition can be also a partition itself that has multiple subpartitions. So, for example, with 4 subpartitions, you spread the load of inserts, because with hash, then the inserts, they can happen to all 4 subpartitions themselves. Now, all 4 of them will need to be extended at some point, but the lock will happen only to the subpartition. So the other inserts happening against the other subpartitions will not have to wait. So you, with 4 subpartitions, you reduce by 75% the likelihood of this to happen. Right, and this, as there are fewer inserts happening because you spread the amount of inserts, then the lock is shorted itself, and you don't have many backends piling up waiting on the lock itself.
So you're both siloing the risk as well as segmenting the risk in terms of the duration if the situation was to present itself.
Exactly, yes.
Great, thank you. Okay, on to upgrades and patching. As mentioned, this is something that you're going to have to handle daily, or at least certainly on a semi-regular basis, to make sure that what you're operating is current and has obviously the most up-to-date either defects or minor enhancements or major enhancements if we're talking, significant major versions. But there are some scenarios you can run into as you go through this process, and it's important to have the right partner along the way to make sure that if you run into those scenarios, you're able to get through those as gracefully as possible. So in the first example, we saw a customer that hit the out-of-order XID insertion against the known assigned XIDs. So what was the problem that they actually hit, and how did we go about identifying it?
Yes, this error was saw in the logs, in the standby logs. So the customer changed the WAL archive location, and they were changing the restore command in the standbys. So they changed the recovery conf on the standbys, and this change requires a standby restart, Postgres restart on the standbys. So they did this to all the standbys. and actually there were two of them. And when trying to start Postgres on the standby, Postgres was not starting, and instead it was failing because of this error out of order XID insertion in non-assigned XIDs. So the issue was happening on the primary, and when checking the primary, we saw that there were very long, there were very old running transactions that were exceeding the architectural limitation of 4 billion XIDs. So in this situation, the standby was not able to start because of what was happening in the primary. So at this point, the customer had no standbys, and the remedy to restore partially the high availability was to rebuild one of the standbys. Now, this took some time, of course, in support work together with the Postgres development team to be able to investigate this issue. And we found a bug in the Postgres standby startup source code. So this was fixed, and we implemented the hotfix that was made available to the customer. So they were able to apply the hotfix to the other standby that was not starting, because one of them was already rebuilt, and the other standby that was not starting, the customer was able to apply the hotfix, and Postgres started without the standby needing to be rebuilt.
This is a great example of a layered approach to solution, right? Because with the right partner, you not only have a remedy that gets you up and running in the most practical senses, but you also have the added benefit of having that same partner produce an actual patch for the builds on which you might be operating. And finally, because of the influence and the involvement and the direction and the execution that EDB has in the community, we're able to get those patches actually into community, right? So we're kind of carrying the entirety of the outcome needed for this customer, and obviously any others who could run into this, from remedy all the way through to refinement of the overall open source project. So this one really kind of highlights how cool it is to have the right partners when you're going into a journey on Postgres. So upgrading from Postgres 11 to 13, this customer experienced failing on the database containing tables with OIDs. So this one's kind of interesting. Why don't you tell us a little bit about what we understood about the problem and how we went about identifying the cause of the OID issues?
Okay, yeah, so PG upgrade, when performing an upgrade from a version that is older than Postgres 12 into a version that is Postgres 12 or newer, if there are any tables that were set with OIDs, which is a feature that was made obsolete in Postgres 12, then PG upgrade itself will fail, and in the output message we will see a list of tables that had the with OIDs. So this field OID, in this case, it was actually used by application. So this case was more complex than simply perform a schema upgrade without the OID field, because applications relied on this OID.
So how did we go about getting this customer from the problem they were experiencing into solution?
Yeah, so we worked together with the customer on this, and we designed a procedure to be able to first of all identify which of all those tables with OIDs were actually used by application. This is information that only the customer can provide. And we work together with the customer with this procedure where we, for each table that was actually used by application that had the OID field, we created a trigger in a single transaction. We created a trigger and a new field, a new OID field right? So this new OID field was existing in Postgres 11, and it was not used by application. Application was using the original OID field, but the trigger was making sure that the actual value that is copied by the original OID is copied into the new OID field. Okay, so also the trigger only works with new rows being inserted or updated. So the history of the table, we also instructed the customer to copy from the old OID field to the new OID field, from the original to the new OID field. So this trigger can be kept running like that for as long as the customer needs, in the sense that the next step is to perform an upgrade using logical replication, right? So only the new OID would be created on the target database, and logical replication can be kept. First, an initial sync is performed to copy the existing data, and logical replication, the connection can be kept for as long as the customer needs to keep the Postgres 13 database in sync with the Postgres 11 database, right? Receiving all write operations that are happening in the source database. So the cutover was important because it was not only a matter of switching the application from 11 to 13. The cutover required a step of dropping the trigger that was created and renaming the field, the new field that was created, and associate this field with an actual sequence, which value we also had to double check, and it was all part of the script that was tested.
So, given the thorough effort that we went through on this, it's a good highlight to show that it's not necessarily just about guidance, advice, best practices, or break fix. It's also really kind of ensuring that whomever you're relying on from a support perspective for Postgres, that they really have the best partnership in mind and embodied in how they collaborate with anyone going through or continually running in a Postgres environment, right? Because this is certainly something where it wasn't necessarily broken, but the customer needed help in how to get from where they were on 11 to 13, in spite of the challenge they had with the OID requirement. One question that was asked relative to 11 and 13, in upgrading from 11 to 13, in general, should the practice be to upgrade the standby first? I think the answer is it depends, but I'd like to kind of hear a little bit more of a thorough input from yourself, William.
Yeah, so the standby is not physically compatible across major versions. So you can't have a standby on 13 and the primary is running 11 unless you have, instead of a physical streaming connection between them, you have a logical connection between them. So the standby can be 13, but only if you have logical standby, not physical standby.
Right. So the only time that you really want to see those major version differences is if you're using logical replication.
Exactly. So when performing PG upgrade, you can you actually run PG upgrade on the primary because it requires it requires the primary. So you can, for example, build a standby using physical streamer replication, and then at the time of the cutover, you can promote the standby, which is a fast operation, and then you can run PG upgrade against this standby. Now, if the standby is a cascading standby, then it can have other standbys attached to this standby. When you promote it, and if you do the process in the right order, in the sense that after the PG upgrade, you can't start Postgres, then you can run rsync on the standbys to have them also upgraded to the latest major version, to the target major version.
And there was a follow-up question, should the primary and standby run on the same versions at all times? Well, absent the caveats that we just put forward, when we're talking about major versions, the answer is yes. Minor versions, there's more forgiveness in terms of running on different versions between primary and standby. But of course, where you've got different minor versions, then whatever has the most current is also going to be the most resilient and have any of the bugs that have been addressed in those minor versions that have progressed since the version of the standby. But there's generally not an architectural prevention when you're talking about minors. That's one of the obvious flexibilities of Postgres itself. All right, well, awesome. Thank you very much, William. We had a couple questions that were standing, and I want to touch back on those. One was referencing something we had said earlier on, which was, when you say development, who are they? So collectively, EDB's development and support organizations total about 400 people globally, spread across a couple dozen countries. And actually, when we're referring to development, we could be referring to one or both of those parties, because we have contributors and committers that are straddling both of those populations. So, where you look at what we bring into the picture, it's often that we're bringing enterprise capability to the freedom of an open source project. So when we talk about working with development to author the hotfix, we're really talking about a function within our own teams or a superset of our teams. There was one last question that was posed, which was, currently we are using open source Postgres and we'd like to discuss Postgres support models. Can you please share the contact details? We'll certainly follow up with you, Karuna, following the conclusion of the webinar, and we'll make sure that we reach out to get things moving there. Well, thank you again, William. I really appreciate it. And for everyone who hung on throughout the entirety, certainly, again, really appreciate everyone's participation. We had some really good questions in there. And for those who are looking to potentially reach out, certainly there are many ways to do so. We tend to be very transparent and available to everyone, the community, customers, potential customers. So if you are interested in reaching out, many will get a copy of this deck. You'll see both my contact details as well as William, but generally, certainly go via the website and you can get a hold of us through any number of means. Thank you.
Thank you.
Awesome. Thank you so much, Jamie and William, for such a great presentation. And obviously, thank you to our attendees for joining us and for your questions and participation. And Jamie, you kind of covered it all there. So like Jamie said, you will receive the slides and the recording as soon as we can get those to you. And there will also be some options to contact our team through there as well. But of course, you have their contact information personally in this deck. So please do reach out to our team with any questions you may have post-webinar. And thank you again to our attendees. Thank you, William and Jamie, and I hope everyone has a great day.
Thanks, Crystal.
Bye, guys.